Our next topic is uniform circular motion and give some examples. What do you mean by uniform circular motion? In our daily life, we come across many examples like the motion of a fan, motion of a flywheel around the axis, motion of an electron around the nucleus, and motion of planet around the sun. These examples are of uniform circular motion. Now, what do you mean by uniform circular motion? When an object is moving along a circular path and at every point of the circle, its direction is changing. When the direction is changing, then it means its velocity is changing, but its speed is kept constant. This type of motion is known as uniform circular motion. Now you can define: if a particle moves along a circular path with constant speed but variable velocity is known as uniform circular motion. And the examples are given here. Now, next question arises here: how uniform circular motion is an accelerated motion? Dear students, the accelerated motion is that motion when the velocity of the object increases with respect to time. And here also the velocity is changing, means the direction is changing at every point of the circle, so velocity changes and hence it is counted as an accelerated motion. The next term is angular displacement. Angular displacement is somewhat similar to the linear displacement, but here the body is moving along a circular path, so we will trace the angle and the displacement in terms of angle will give us the angular displacement. Consider a particle is revolving around a point O, that is the center of the circle, with radius r. Let the position of the particle at time t equal to 0 is p naught. But after some time t, the object is at point A, and after a very small change of time, the object is at point B. Now, from A to B, the displacement is delta theta. It means initially the object was having angle theta 1 represented here, and then angle theta 2 at point B. So between this distance delta s, the angle is theta 2 minus theta 1, that is equal to delta theta, and this delta theta is known as angular displacement. So we can define the angle described by the particle about the axis of rotation, that is the center, in a given time is called angular displacement. The angular displacement is a vector quantity and its unit is radian. Why the unit is radian? Because you can calculate it as shown in the figure. This angle theta is equal to arc upon radius. Arc is having unit meter and radius is also having unit meter. So in this way it is a unitless quantity. But we measure the angle theta in terms of degrees or in terms of radian. So angular displacement is having unit radian. It is denoted by RAD, radian. But it is a dimensionless quantity having dimension m0, l0 and t0. Next is angular velocity. Angular velocity is represented by omega this omega. For this, consider a particle on the circle of radius r at time t, and suppose the particle is at point B after small time delta t, and delta theta be the angular displacement. Now, what is angular velocity? Angular velocity is the ratio of angular displacement to the time taken, or you can say the angular displacement traveled by the object in a given time. So you can write it as omega is equal to delta theta by delta t. Delta theta is angular displacement, and this is a very small change of time. This value is showing you the average value. Now you can change the average value to instantaneous value. What is the difference between average or instantaneous value? The instantaneous value is the value for a very small interval of time. So we will take the limit that delta t tends to 0. Time is taken to be very small. This time is approaching to 0, but t is not exactly 0. It is very near to 0 and very small change. So this delta theta by delta t, by applying the limits, this average value can be converted into the instantaneous value, that is a very small change. Now the unit of angular velocity will be radian per second, because this theta is having unit radian divided by time, that is radian per second. And the next term is time period. What is the time period? It is the time taken by a particle to complete one revolution along its circular path is known as time period. It is denoted by capital T. You have studied the time period in class 9th also, that is the same thing. Next is frequency. The frequency of a particle is defined as the number of revolution completed by a particle in 1 second, that how many revolution that particle is taking along a circle, and standard value is one complete round in a given time period, capital T. So the frequency is written as T nu is equal to 1 by T. This nu is the frequency, and SI unit is second inverse, or you can say hertz. Hertz is equivalent to second inverse. Now next is